Okay, in today's lesson you're going to be learning about the volumes of pyramids and cones. So when we talk about a pyramid, we're talking about a polyhedron in which one face can be any polygon and the other faces are triangles. So the base of this pyramid is a square or rectangle. You can see that they all meet. There are four faces that are triangles that meet at one vertex at the top. The formula for volume of a pyramid is 1/3 of its volume as if it were a rectangular prism. So 1/3 of the area of the base times the height. So length times width times height divided by 3. In this case, notice that the height is what we call the altitude, and if you can kind of tell, that dotted dashed line is going down straight from the vertex at the top through the center, like to the base. So it's perpendicular to the base, this height of how far away that vertex is from the base. And when they're talking about slant height, what they're talking about is, if you look at the triangular face, I'll change colors here. Let me get something kind of bright. The slant height would go on the outside face, right, and would be perpendicular to the side. So this is L, and that is known as the slant height. Okay, so one thing that is true is that if you look at the vertex at the top, the slant height, the height of the pyramid, and half the distance out would form a right triangle. So if you know the slant height, and you know, say, the base of this right triangle right here, the base, you could calculate the height of the pyramid if you need it. Okay, so you can use your Pythagorean theorem concept. So for instance, if the length of the whole edge of this pyramid were 16 inches, the base of that right triangle would then be 8 inches, because it would be half that whole edge of the rectangular prism. So lots of information here. Again, the slant height would be used in surface area when we do that next to calculate the area of the triangular face. You'll need the height of the triangular face, and that's what the slant height is. So it's on the outer edge, whereas the height here is the altitude, or how far away the vertex is, this vertex is from the base. So let's find the volume of a square pyramid. The base edges are 15 centimeters, and it has a height of 22 centimeters. And you can see that that's the altitude height, the distance that the vertex at the top is from the base. So using the formula, you would take the area of the base, which is length times width, or 15 squared in this case, because it's a square, times the height of 22, and divide by 3. So length, width times height times 1/3. And do the multiplication, and make sure you have your unit labels. Okay, if we're going to find the volume of a square pyramid with base edges of 16 feet long and a slant height of 7 feet, notice that we cannot use that height. We need the height that is going to be the altitude that the I do such a lovely job, don't I? This height, not very straight, but you know what I'm talking about. So the height that the altitude, the vertex, is from the base, we can make this right triangle then and use that information. 16 feet just happens to be the same number I used in that previous example. So that makes the base of this right triangle 8 feet, the hypotenuse 17 feet, and then you can see already they've started the Pythagorean theorem. So let's see where that goes. So we need to know what this height is, and then we use the Pythagorean theorem. So h squared plus 8 squared equals 17 squared. H squared is 225, so it is 15. So we can put that 15 in, multiply it, and find the volume of 1,280 feet cubed. Okay, for cones, it's pointed like a pyramid, but the base is a circle. Again, you have your radius and your height, which would form a right triangle with the slant height. So there is a slant height on a cone as well. The slant height would be this height right here that forms the right triangle. Okay. Again, it'll be helpful for us to find the lateral area of the cone, that curved surface, when we do surface area, but it will also be useful if we know that measurement to either find the radius or find the height if one of those is missing. Remember the base, the area of a circle is pi r squared. And it's the same. It's just as if it were a cylinder, but it's a third of the volume when it's a cone. So let's find the volume. We know the height, and it has a diameter of 6 inches. So if we know the diameter, we also know the radius. So we have a third of pi r squared times the height. Use the formula. And in this case, if I take 33 times 3.14, I would get, if I used 3.14, I would get 103.62 inches cubed, which you could see then would, so 33 times the pi button would round, so they used the pi button right here. So again, we'll be, flexible. The directions might say to use 3.14, and we may be rounding to a whole number. Either way, it would round to the same whole number of 104, so we're pretty safe there. But we'll allow, like, plus or minus 1 or 2. We'll know if we're getting close and using the right formula, and it'll just be rounding. And that's why a lot of times we use this approximately, okay? All right, if we have a composite figure, we'll do the volume of the cone first, and then we'll do the volume of the cylinder. So for the cone, we know that we're going to have a third of the area of a circle and the base. And we know that since they share, the cylinder has a radius of 8 centimeters, that will be the radius of our cone as well. So a third of 8 squared times pi times 10, which is the height of the cone, and we'll get approximately 670.2 cubic centimeters. Then we'll find the height of the cylinder, which is pi r squared h. We don't have to take a third of it, and then we'll add them together to get a composite of 1,474.4 centimeters cubed. In example 5, let's solve for the missing side or the missing variable. The following cone has a volume of 110 pi. What is the radius? So we'll just plug in what we know for the volume and work backwards. So 110 pi, and this, if you leave, if you're given pi and then you're dividing by pi to find the radius, the pi's will cancel out. So that'll be one way to make the math a little bit easier. So we're going to do a couple things here. We divided both sides by pi first. So the right side divided by pi cancels that pi. The left side divided by pi cancels that. So we were left with 110 is equal to this. Then we've divided both sides by 10 as a second step. So dividing the right by 10 gets rid of that 10. Dividing 110 by 10 gives 11. Last step will be multiplying both sides by 3. So if 33 is equal to the radius squared, and you take the square root of that, you would get approximately 5.7 centimeters for the radius. So what have we learned today? We've learned that the volume of cones and pyramids can be found using the formula volume is equal to 1/3 of the area of the base times the height.